Let's say that we had some point, for example 3, 2, that happens to be on the terminal side of an angle. Then the length of this red line is the same as the value of y, because that's what the y value measures, is how far the point is from the x-axis. And similarly, this blue segment has a length of 3. It's the x value of the point. So now we have a right triangle with one leg equal to 3 and one leg equal to 2. We can find by the Pythagorean theorem the length of the segment from the origin out to the point. That's really that's just the distance formula, but it's a Pythagorean theorem that makes that work. So with this 3, 2 right triangle, we'd like to find out how long the hypotenuse is. Of course, by the Pythagorean theorem, we know that h squared is equal to 3 squared plus 2 squared. So h squared is equal to 9 plus 4. H squared is equal to 13. So h is equal to the square root of 13. So this green segment, the hypotenuse of this right triangle, is the square root of 13. Now let's call this angle alpha. So here we are zoomed in on our picture. We knew that we started with this point, 3, 2, that this length of this segment was going to be 2 because that's the y value of the point. This segment is going to be 3 because that's the x value of the point. We use the Pythagorean theorem to find this. And so we're talking about this angle alpha, and we'd like to find the 6 trig ratios for this triangle. So you'll need to know what each of those trig ratios are. For example, the sine is the opposite over the hypotenuse. So therefore, the sine of alpha is going to be 2 over the square root of 3. So sine of alpha is equal to 2 over the square root of, the square root of 13. Okay, I corrected the typo. The sine of alpha is equal to 2 over the square root of 13, opposite over hypotenuse. Similarly, the cosine of alpha will be the adjacent over the hypotenuse, so 3 over the square root of 13. And of course the tangent is the opposite over the adjacent, so that's 2/3. It's worth noting that the tangent is actually telling us the slope of this line because it's talking about the rise over the run of this ray that starts at the origin and goes on out. The cosecant is the hypotenuse over the opposite, so the cosecant of alpha is going to be the square root of 13 over 2. Now that's enough information for you to finish this problem, because you'd need to know the secant of alpha, which happens to be the adjacent over the hypotenuse, so that would be 3. It happens to be the hypotenuse over the adjacent, which would be the square root of 13 over 3, and the cotangent would be 3 over 2. So to be able to solve this problem, the things that you needed to know is this Pythagorean theorem, so that you could identify these two sides, the length of those two sides, and then use the Pythagorean theorem to find the length of the hypotenuse, and then know what the trig ratios were to find the 6 trig ratios. Now suppose that we had a point in a different quadrant. For example, let's take this point J, which happens to be -3, -4. And let's think of it being on the terminal side of some angle. And again, let's call our angle alpha. So this red segment has a length of -4 because the y value of the point tells how far the point is from the x-axis. And this blue segment is going to have is a -3, because the x value of the point tells us how far we are from the y-axis. So now we've got this -3, this -4. We can find the length from the origin out to this point by the Pythagorean theorem. Now in this case, -3 squared is 9, -4 squared is 16, 9 plus 16 is 25, and the square root of that is 5. So in this case, it was kind of nice because we had a Pythagorean triple here, and so the hypotenuse ended up being an integer. That's just kind of nice. Very often you end up with a square root there. But now we could start talking about sines, cosines, and tangents, and cosecants, secants, and cotangents. So the sine of this angle theta, whose terminal side goes through the point -3, -4, is going to be -4 divided by the length of the hypotenuse, which is 5. So -4/5. Can you find the other 5 trig ratios? So in this video, what we've examined is if we know what a point is on the terminal side of an angle, we can find all the trig ratios for that angle.